All right, hopefully you folks are here to see continuous delivery best practices with Jenkins and GKE. Welcome to the party. There's actually a party going on outside, which is really awesome. I'm between you and whatever's going on out there, but thank you for spending your time here. How many folks use Kubernetes? Perfect. Okay, so we've got a good group of people. How many folks are using Kubernetes Engine? All right, and how many folks are using Jenkins? Yeah, everybody, perfect. All right. So I am Vic Iglesias. I'm a cloud solutions architect with Google Cloud. If you need to find me, my Twitter handle is VicNasty, and I'm relatively responsive. I have no SLA at the moment, but if you start paying me, maybe I could get an SLA going. So I have been using Jenkins for a really long time. As you saw in the keynote today, I've gone through many iterations of Jenkins deployments, using it with different teams, trying to share Jenkins, trying to scale out and shard Jenkins. I've gone through a lot of different use cases with Jenkins, and most recently have been helping our customers at Google Cloud to use Jenkins, most specifically with GKE. My coworkers are big fans of the memes, so they make memes about me and Jenkins and how much I love Jenkins. Jokes on them, I was in the keynote at Jenkins World, so so this is one of them. Yo, dog, I heard you like Jenkins, so I wrote a Jenkins plugin to launch your Jenkins pod to monitor your Jenkins jobs. And this is going to kind of set the tone for what we're doing today and talking about Jenkins on GKE. We're going to have a brief overview of Jenkins, like super brief. Everybody's pretty familiar. Then we're going to talk about a Jenkins journey. And this is kind of some of the learnings that I've picked up along the way as I've used, deployed, and worked with Jenkins over time. Then we're going to talk about best practices on GCP, how to install and deploy Jenkins and maintain Jenkins on GCP. Then we'll look at continuous delivery with Jenkins and Spinnaker. Brief overview, we all know it's a build server. It has triggers. It's a great way to test and build our software. It also has a large ecosystem of plugins. How many people here are using 5 plugins or more? Yeah, most people. How many people are using 10 plugins or more? Okay, getting risky. How many people are using 20 plugins or more or have lost count? Yeah, those ones. It's painful. Yeah, I've been there. So it's a blessing and a curse. As you onboard new plugins, there is some overhead that you have to maintain those plugins if you're not the maintainer yourself. One of the nice things about Jenkins is it works on a bunch of different platforms. So we can use it on Linux, we can use it on Windows, and we have Mac, the ability to launch it on Mac because we're using the JVM, which runs anywhere. So when people ask me, Vic, what should I do for CI/CD? I just sprinkle a little Jenkins on it and move along my way. It's not actually that simple. There's a lot more to getting Jenkins to scale and work well in really any environment. You learn some tricks of the trade as you go along. So here's an example of a journey that you may be familiar with as you work with Jenkins. Day 1, someone says, we're sick of running these builds on our dev machines. We need a shared place to unify our CI process. So someone says, OK, I got this. Don't worry. I'm going to set up the Jenkins. They find probably the crappiest machine they can possibly find. They put it on like a Raspberry Pi that can barely run the JVM. They launch it. The UI comes up. They put a bash script in there. They load up their dependencies that they need for their build process, maybe Maven or some of those build tools. And then Jenkins is triggering off your builds. You're stoked. You've solved that problem for the day. And what actually happened was you ended up with Jenkins installed on there, which is that JVM process that's running the master. You are going to be able to launch build executors that are going to run your build scripts. And you have all your build dependencies in there that are the things that you depend on, like Maven and Gradle and so forth. The other thing that you have on that box is a file system, and that's the Jenkins Home. How many people are familiar with the Jenkins Home? Yeah, we're all big fans of Jenkins Home, and that's going to have our configuration in there. It's going to have any build artifacts that are archived during the build process, and it has our build workspaces, that scratch space that we give to each of the jobs. Cool, so everything's OK for a little while, but then something like this happens. How many people have seen this? Most of us, yeah. Jenkins is falling over for some reason or another. You start to dig in, and you realize that your builds are taking all the resources from that awesome Raspberry Pi, and so you want to be able to scale out your build executors to other machines. So you decide, OK, I'll find 6 more Raspberry Pis, and I'll install the JVM on it, and I'll use those as build executors. I launch the agent on there, point it at my Jenkins master, and now I've scaled out my builder fleet, which is really cool. Now people can get better parallelism on their builds. Your build times are going down. Again, you've saved yourself some time, and now you move on to the next thing. It's breaking again. You're not really sure why. You look into it. We've run out of disk space on our master. We were archiving a lot of artifacts. We don't have a great policy for how we're getting rid of our artifacts, so we've filled up the Jenkins home file system, and things are busted. What are we going to do now? Well, we can use something like an object store in order to store these, something off the Jenkins master. We configure some object store, maybe Google Cloud Storage, for example, to save all of our artifacts. And now we have a relatively infinite amount of storage at a cheap price in order to store our build artifacts, our jars, our Go binaries, things like that. Cool. We are moving along. We're at day 150, and our team is still happy and still productive with Jenkins. At some point, your team's going to realize that their dependencies are not all the same. You start to run some builds with Java 1.7, some with 1.8, you're figuring out that there's different pieces of dependencies that you need to have co-located on these boxes, and having these Jenkins agents manually built is not going to work out. So you decide that you're going to start using containers in order to containerize the dependencies. So every team can define their own build dependencies in a Docker file, and then those builds are going to run on your build agents in their own isolated space. So you're basically handing over the build dependencies to developers. They're happier, they have more control. You're happier, you have less problems to deal with, right? Here you can use the Docker plugin, which will run these Docker containers for you on those hosts. Awesome. Next, your team's telling you, we're having a tough time managing our build process in the Jenkins UI. We're developers, we want to have everything in Git. We want to be able to have this in source control. And most of all, we want to be able to roll back when Jeff screws up the build, which is happening relatively often. So now in order to do that, you're going to use Jenkins pipeline. How many folks are using Jenkins pipeline? All right. By next Jenkins World, I'm sure we'll all be using Jenkins pipeline, right? Jenkins pipeline allows us to define our build process next to our source code. As we commit changes to maybe how our tests need to run, we can update that in either the same commit or in another commit before we push to our source code repository and change our tests and our build process at the same time. So it's a really powerful thing. Again, we've handed over more control to our developers so they can just do things on their own, and we have less responsibility. Awesome. So now you've got all these little Jenkins pipelines all over in every repo. You paint them across your organizational landscape, and you're really happy. Next, you realize that those fixed set of hosts that you have is not actually going to work for you. You need to have much more scalable builds. You realize that between 8 and 5, you need 100 workers, and the rest of the day, you need maybe 2 or 3 to just to handle some scheduled jobs. So you're starting to look at how can I create build agents on demand. And there's a couple options that you can turn to here. Either you can look to the Kubernetes plugin, which will provision a Kubernetes pod for you, and we'll go over that in a little bit. Or you can use the Google Compute Engine plugin, which will spin up a full VM. Our boot times are around 30 seconds per VM, so you're only paying a little bit of a tax there. Once it spins up that VM, it's going to run your work on there and leave it around for a configurable retention period. If no work lands on it again, we'll terminate that VM. So you get a nice scalable build system out of that using either Compute Engine or Kubernetes. Next, teams start to say that they are competing for plugin space on your Jenkins. They need to have plugins that are not interoperable on the same Jenkins. So you decide that you're going to shard out your Jenkins usage. You're going to have to install Jenkins multiple times, again with the same patterns that we've built up over the last year. And you're going to decide that for each team, you're going to give them a specific set of plugins that they can define and install. And one option that we'll go through today is using Helm to deploy Jenkins into a Kubernetes cluster. And you can define declaratively what that configuration is going to look like. All right, so now I've just taken you through this faux journey of Jenkins, how many folks can kind of relate to how that scaling process works, right? That's just kind of how you go through things until it breaks, and then you move to the next problem and so forth. But what if you just wanted to do that today? How do I get there right now in practice? Like I said, you can use Helm. Helm is a package manager for Kubernetes. It allows you to install applications really easily and also configure them declaratively. That's a really powerful concept, and in Jenkins world, in the Jenkins world, not at Jenkins world, it allows us to define plugin versions that we can explicitly put in our declarative manifest. Another thing that allows us to do is to easily upgrade Jenkins. We change one parameter in our configuration file and reapply that to the cluster, and it'll automatically update Jenkins. And it also has a lot of security defaults set for you. So Kubernetes allows you to, for example, lock down what Jenkins can do within the Kubernetes cluster. It allows you to define what pods can access Jenkins itself and what things your Kubernetes or your Jenkins executors can access outside of the cluster. So these are really powerful constraints that you can put in place to make sure that you have least privilege for your CI workloads. And these things are going to come default out of the box for you. So what does it look like to install Jenkins with Helm? You would use the command helm install. Then you would point it at a repository. Stable is the default repository, and we have a Jenkins Helm chart in there. So we'd say helm install stable Jenkins, and then we would pass it a values file. And this is basically a configuration API that we've defined in the Jenkins Helm community for what we think you need to provide to Jenkins in order to get an installation. One of the things that's most used is to list the plugins. So here we see where you're installing the Kubernetes plugin, credentials binding, and Git, for example. A lot of things that a lot of users actually want to give Jenkins a lot more memory, and we know that Jenkins loves to use its memory, so we can set the number of CPUs and the amount of memory that we're going to allocate. In this case, I'm actually disabling the default agent configuration, and we'll see in a second how we would define our Jenkins agents. We can set how big we want Jenkins home file system to be. In this case, I'm only using 100 gigs. I'm not going to be storing my artifacts there. I'm going to use the Google Cloud Storage plugin to store my artifacts, so I don't expect this to get huge. And then I'm going to enable the security features that I talked about earlier, the network policy, which limits the network access of Jenkins and its build executors, and then RBAC to make sure that Jenkins can't access and do weird things to the Kubernetes API. Cool, so what do I get out of using Kubernetes Engine in order to run my executors? Well, first, Kubernetes Engine allows you to auto-scale the number of nodes in your Kubernetes cluster. So as your build process needs more agents, Jenkins is going to talk to the Kubernetes API and say, I need to run more pods. Once those pods go to running, it's going to run its work and be done. At some point, your cluster is going to run out of capacity, and Kubernetes Engine will look at the pending pods and see that they can't be scheduled because they need more CPU or RAM. And as it detects that, it's going to spin up another node in your cluster and allocate that pod to the new node. So all automatic. You don't really have to do anything other than define the minimum and maximum. The other thing we get out of this is we've now kind of been forced into defining our dependencies as container images because they're running inside of a Kubernetes cluster, and that's all it can do. So you've kind of forced that on your developers, for better or worse. And we have these nice ephemeral workspaces. So we know that there's no cruft left around from previous executions that can mess up our build process. If you want to save money on your build workers, you can use preemptible nodes, which save you about 70% out of the box for your Kubernetes node pricing. And that comes with a side effect that after 24 hours, we will terminate that node. So if you have a CI workload that can take some preemption, so it can restart really easily, maybe you have retries set on particular steps, then you can save quite a bit of money by using preemptible nodes in GKE. Another thing you can do is to set soft and hard resource limits. So you might say that a build process can, at a minimum, will use 1 gig of RAM, but it can go up to 8 gigs of RAM throughout its process. And then you can co-locate these pods on the same node in order to share resources. Previously, as we installed with Helm, I said that I was going to disable the default agent configuration and that I was going to force my users to define their own agents. So this is an example of a pipeline file where I'm using the Kubernetes plugin's ability to pass a full YAML specification of the pod that I want to run this build. The interesting thing here is that I can have multiple containers defined. So I can isolate my build dependencies in various images. So I might have a test image that has a bunch of things that I need in order to do integration tests, separate from a build image that has only the things that are required to get me an artifact. So now developers in their pipeline files are defining the exact configuration that they expect for their builds. One thing that they have the ability to do here too is to set environment variables and all of the CPU and memory limitations that they expect. So you kind of hand over the full orchestration aspect to your developers, and they really don't need to do anything crazy. One thing that they can do is run commands in various containers. So here in the bottom, you can see that I'm using the Golang container in order to run Go test. I could have other containers and run individual steps in individual containers. With all this and handing back control of the build environment to developers, you're going to have to ask them to build containers. And this can be done with Google Container Builder or Cloud Build, as it's been rebranded. And basically, Cloud Build allows you to easily define a process for creating Docker images and pushing them to a registry. So as your developers commit, a build is automatically run to run their Docker build and pushes that to a registry with a tag. And kind of offloads the need to have Docker hosts running in your infrastructure. Here's an example flow that you would use. You have some source code change. Maybe it's from GitHub or GitLab or Bitbucket. That then is triggered. It triggers a cloud build, and that automatically pushes your images into Google Container Registry, which hosts your images. I told you about using cloud storage for your artifacts, and that can be done through the cloud storage plugin. You install that plugin from the plugin index, and then you give it some of your Google Cloud credentials, which are in the form of a service account key. Then in your build process, you can set up a pattern that you want to archive, or this is obviously in the graphical interface, or you can do it via the pipeline file. So next we'll do a little demo of the first part of this, which is CI with Jenkins on GKE. So first thing I'm going to do is show you my build container. So I have that in a directory here. I'm calling it my test image, and it has a Docker file. So if I go to that, I see here that I'm using Golang. I install a couple of my dependencies in there. I'm using Golang 110 right now, and I want to use Golang 111. So I just save that change, and I can see that here. Commit that, go 111. I'm actually going to add a tag here for version 9.0, and I'm going to push that up to my Git repository. Awesome. So once I've done that, I should see in my cloud build that a build has been picked up. So it detected that change. The trigger that I have right now is that it's triggering on any tags that are pushed. As that tag reaches the cloud build service, it knows to add that tag to my image. So my image will be pushed with the 9.0.0 tag, which is the same as the Git source code, so I can have some traceability between those two. So next, I want to be able to use this test image. So I'm going to go to my Jenkins file, and I'm going to change my test image here to point to the one I just built. All right. So now that I've done that in my app directory, I want to build and push that. Commit it. Use version 9. And push that. Cool. So now I should be able to go to Jenkins. All right. And it should pick up that change relatively soon. I have it checking for the SEM changes, but we'll just start one. And go check out what's happening now. So the first thing it's going to do is going to look at my pipeline file and see that I have a pod template and that it needs to kick off a node with that. So in my Kubernetes cluster, I should see that it's starting to think about creating a new pod with my definition. So here, Jenkins is reaching out to the Kubernetes API and saying, I want you to run a pod with this definition. We should see that starting soon, right, Jenkins? Takes a little bit of time sometimes to provision new executors. Come on, Jenkins. I know you can do this. Mid-demo. Maybe not. Taking longer than it's ever taken. Try this again. And check the logs. Welcome to live debugging Jenkins talk. Let's see here. We'll go to the logs. This is what I know. What have I done? Oh, triggering. OK. I'm not sure why that is not kicking off at this moment, but you get the idea. We'll look at an old build here. Oops, here. And check out the log here. So what this pipeline is doing, it's going to check out my source code. So that's the repository that I pointed it to. Then it's going to run in one container the go test command. So that's it doing that right here. And next, it's going to run in a separate container the Google Cloud build command in order to create an image from my source code. So that's it actually shelling out to gcloud command. That's going to upload my source code to cloud build, and cloud build is going to run my Docker build process. So I don't have to have Docker installed or nested inside of my Kubernetes cluster. And then it completes successfully. What a great demo. So I'm going to check one more time, just hoping that it actually provisioned it. It did not. The rest of the demo hopefully doesn't depend on that. All right, so now that we've got our CI process complete, let's move on to continuous delivery and how we would deploy to Kubernetes. So let's take a look at that. All right. So how many folks of the Kubernetes users are using kubectl apply? Yes, OK. So a lot of the Kubernetes deployments are using kubectl apply, or Helm does its own application of Kubernetes manifest. But at the end of the day, you have some Kubernetes definitions, and you want those applied into a cluster. That's going to be one of our greatest tools in order to deploy with Kubernetes. But the first thing you're going to have to ask yourself is, which cluster do you want to deploy to? You may have different clusters for different use cases. Each developer might get their own cluster. Or you might have a staging cluster and a production cluster. So in order to decide that, you can use Kubernetes contexts, which are defined in your kubeconfig. And the kubeconfig is broken down into a few different sections. The first section is clusters. This is where you define where the API server for your Kubernetes cluster lives, some information about the cryptographical signing that you're going to use in order to get there, and you can give it a name. And then the other thing is how you're going to authenticate with that cluster, and that's the users section. Once you put a cluster and a user together, you call that a context. And that's a way to tell Kubernetes CLI which combination of user and cluster you're going to actually actuate. Once you've got, you can have many contexts inside of your kubeconfig, and then you usually label one as your current context or your default context in order to run your commands. So that's just a quick overview of how Kubernetes configuration works. In Jenkins, you can use the Kubernetes CLI plugin, which has a helper that allows you to wrap your shell commands, for example, kubectl apply, with a particular context from your kubeconfig. The first thing you're going to need to do is upload your kubeconfig into Jenkins, and that will be uploaded as a Jenkins credential. And then you can use the syntax on the right in your pipeline in order to define the cluster that you want things to go to. So here in the top part, I am deploying to Canary. So I tell it to pull the credentials, the kubeconfig from the kubeconfig credential, and then pull a context out of there. I'm using the context Canary in the top block. And similarly, in the bottom block, I'm using the prod context. Cool. So how should we roll out the code? Now that we know where to point things to, how should you roll this out? Well, how many folks are doing blue-green deployments today? Some. How many people are doing rolling update? How many people don't update their code once they launch it? No? Okay. Just checking. It's late. So if we wanted to do a blue-green deployment in the Kubernetes context, we would first deploy a Kubernetes deployment. We would add some labels to that deployment, which is a really important part of this. And then we would map a service to that deployment using the same labels as the selector, right? So now I have these selectors choosing all the pods that are behind this deployment called using the my app label and version blue. Now, if I want to deploy my green version, I would create a new deployment, change the version to green, and as I deploy that, pods are going to start rolling out, but they're not going to receive any traffic until I decide that the service is ready to be changed over and bring the green one live. I may do some integration tests against that green version before switching the actual service. In order to switch that service over, I'm just going to change my version label from green to blue, and then Kubernetes is going to start sending traffic to my new service. What would this look like in a Jenkins pipeline? Well, first, you're going to have a build image step, right? You can push this to Google Container Registry. You can have your own private registry, but you need to get an artifact out into a container registry in order for Kubernetes to deploy your code. Next, you're going to create a new deployment. This will be your green in the last example. Maybe you've tagged your Docker image with the build number or something like the actual Git tag or something like that. So you can apply that into your Kubernetes deployment and then apply that to your Kubernetes cluster. Next, you're going to want to verify that that deployment actually went well, right? You shouldn't just trust that Kubernetes, after it returns from your CLI commands, has actually completed the work that you expected it to do. It is a declarative system, so it is working its way towards making that happen for you. But you can also verify using kubectl rollout that things have actually completed from Kubernetes perspective. So it's gotten to the number of replicas that you told it to, and they're all healthy. The next thing you can check is that kubectl get pods, maybe with your label selector, is showing you the number of pods that you expected. Right? These are all verifications that you can do post facto after Kubernetes has accepted your API call. Once we figure out that that green deployment is healthy, as far as we can tell, we may want to switch over the traffic. So now we switch that traffic over using the same label mechanism I showed in the previous diagram. And again, we want to verify that everything is still running as we expect. So what would we do to verify the service? You might check that your service has endpoints mapped to it, that the labels that you decided on as you switch things over are actually mapping to real pods in your cluster. If not, your service is going to get a bunch of 502s. So you might want to verify that. You might actually want to check that your load balancer is actually healthy. You might also want to run a pod inside of the cluster with an integration test or some sort of smoke test to make sure that things are operating as you expect. Once you've verified that, you can delete the old deployment, and then you're ready to do that loop again. So there's a few ways that you can configure deployments in Kubernetes. I just showed a blue-green deployment. One of the more common ways is to use a rolling update. This does require that your application can handle servicing traffic on two application versions at the same time, which is not every application in the world. But if your application can handle that, it's relatively stateless and it doesn't do weird things to the database, you can do a rolling update. So this will bring down pods one by one, or as you can see here, you can change that number, and then bring up the new version and take down the old version in series. So you have a few configuration options that you can use. You can do a rolling update with a max surge parameter. And the max surge says how many to bring up at a time. So this might be something where you're deciding how much extra slack capacity you have to have in your cluster in order to do these rolling updates. If you said that the max surge was 100%, then you'd have to have twice the amount of capacity that your application needs available in your cluster in order to do the rolling update. So something more like 10% or so is a good way to go. You can also set how many pods can be down at a time using the max unavailable. So this, again, will be a small percentage of your fleet that you want down as your rolling update is happening. These numbers can both be either percentages or absolute numbers. Just keep in mind, as you scale up and things, that number may need to change if you're using absolute numbers, so something to coordinate. When you're using percentages, it may not make sense to have a 10% surge if you're using 3 pods. Cool, so now we've talked about going through the rolling update process. How do you make that more robust? Well, first, you have the ability to set a readiness probe on your deployments and your pods. And this is the way that you tell Kubernetes that your pod is ready to receive traffic. This is a very important concept, and it's kind of the place where the application and the infrastructure really meet. So your application is telling the infrastructure that it will be able to service traffic for this endpoint. And you can do that with a health check on HTTP or TCP socket, or by running a command inside your container. So when that health check goes unhealthy, Kubernetes will stop sending requests to your pod. With that, you also have the termination grace period. So you may have some extra work to do once your pod is going down in order to finish servicing requests or doing things. And that may take you a longer time than we have by default, which is 30 seconds. So first, Kubernetes is going to send a SIG term to your process. And your process then should start to clean up the remaining work that it has. So once it's done servicing all of its requests, it can terminate itself. If you reach the termination grace period, we're going to actually just like force kill your process, which may not be something that you can handle. Cool, so next we'll talk about integrating with Spinnaker. And Spinnaker is a tool focused on continuous deployment, right, and continuous delivery. It supports many platforms. Today we'll be talking about Kubernetes specifically, but it's a tool for creating pipelines that roll out your code to your customers. So this is our typical continuous delivery pipeline. Jenkins does a great job of this first chunk, making sure it runs your builds, your unit tests, integration tests, all those plugins that we use to visualize our test results, the ways it handles triggers and artifacts. It's amazing. And then we have Spinnaker, which does a great job of rolling out your code to various environments as you go through. There are 2 main integration points between Spinnaker and Jenkins. One is that you can have Jenkins trigger pipelines in Spinnaker. The other is that you can use Spinnaker in order to trigger a Jenkins job. So in the middle of a continuous delivery pipeline, you may have a stage in your pipeline that runs a Jenkins job, for example, to run your integration tests against staging or a canary environment or something like that. So what does that look like in the Spinnaker configuration? You have pipeline triggers configuration in Spinnaker, and it provides you with a dropdown of the registered Jenkins masters that you have. It's a simple configuration in the Spinnaker CLI. And then it prompts you for which job to wait for. So once you're chosen which job, you can also pass information from Jenkins into your Spinnaker pipeline. And that might be something like a build image that it needs to use for that pipeline in order to deploy your code, or any other information that needs to be passed as metadata into your deployment pipeline. How many folks are familiar with property files? Yeah, so our Java folks are probably relatively comfortable in this land. The way you pass information from Jenkins into Spinnaker is using the property file. And this is what it looks like. It's a key value, set of key value pairs with an equal sign in the middle, 1 per line. And you archive this as part of your Jenkins build. And then you tell Spinnaker which artifact has your properties file. And then those will all show up as metadata inside your Spinnaker pipelines. The next thing I said you could do is trigger a Jenkins job from Spinnaker. So in order to do this, you have, let's say, a job in Spinnaker or in Jenkins that has a few parameters. So for example, here I have a run command pipeline that takes an image, a working dir, and a command to run inside of a container. And in Jenkins, I create a pipeline stage that is a Jenkins stage. And then I point it at which Jenkins master to trigger the job in. which job to trigger, and then it'll automatically pull in the parameters from that job and either let me use the defaults that are provided or override those myself, possibly with information about my pipeline. So next we'll see the demo of CI happening in Jenkins, which hopefully things have recovered, but I know how to hack around that. But then taking that through and seeing how that works in Spinnaker. All right. So here, I'm just going to run my image build, which I'll pull from my old app here. Here we go. So I'm going to shortcut my unworking Jenkins here and run a new container build. So this is, again, exactly what was happening inside of that Jenkins job. It's taking my local source code and uploading that to Container Builder. And Container Builder is then going to run my Docker build for me. So if we go over into Cloud Build, we should see that it's running that process. And it used my existing code. Once it's done, it's pushed it as tag 55. And now we should be able to see that Jenkins or Spinnaker was triggered. Let's see if I have access to my Spinnaker. All right. There we go. All right, so we have a pipeline running here that was hung up for some reason. I'll stop that one. I have my pipelines configured to only run one at a time. So here's the one that was just triggered. And let's take a look at that configuration. So in this case, rather than triggering off of the Jenkins build, I'm actually using the fact that an image landed inside of my container registry in order to kick off my pipeline. And that container registry is Google Container Registry. And Google Container Registry publishes events into our messaging queue called PubSub. And so it's going to let us receive those messages about images being triggered. When we get those images or those messages, I'm going to pull out what the artifact was, which is a Docker image with a certain tag. And I'm going to pass that through my pipeline. And in that pipeline, I have a deploy backend step and a deploy frontend step. So here I define that I want it to replace in my source code, in my Kubernetes manifest, the Docker image that it just received as the trigger into my YAML file, which is coming from GitHub. So I have my, sample app, Jenkins world. So right next to my source code, I have my Kubernetes manifests, and I have those defined in here. And Spinnaker is going to pull these and use these as the deployed manifests in my pipeline. Once it gets the image from the trigger, it's going to replace that image in the image field automatically for me. So I'm always deploying the thing that just triggered my steps. So here we'll see Jenkins deploys, or Spinnaker deploys, and we have the visualization of what it deployed in Spinnaker. So I said previously that we had deep integration for deployment and an understanding of the infrastructure in Spinnaker. And this is one of those views that allows you to see the things that are actually deployed in the cluster. So I can see that I have version 28 deployed here for my backend and version 30 deployed for my front end. And it shows me how many of those are actually running and their health status. So I can see here that I have 4 healthy pods for each of those. Awesome. So what can you do next? So first, we have a few tutorials available that you can run through on your own in your own GCP projects to get a feel for these tools. The first one is the Continuous Delivery with Jenkins on Kubernetes Engine tutorial. And this is a purely Jenkins-based tutorial that uses multiple branches to map to environments in Kubernetes and will take you end-to-end through that process of setting up those pipelines. The next one is the Spinnaker on GKE tutorial, which shows you how to use Container Builder or Cloud Build as your place to build images, and then triggering those in Spinnaker in order to deploy those out into your Kubernetes Engine clusters. But finally, and one of the ones that I think is most important is the Kubernetes or the Jenkins on GKE tutorial. And this is for folks that are not ready to jump into containers quite yet, but they do want that scalable fleet of workers. This will allow you to create GKE VMs for your builds, scale them up as you need them, and automatically turn them down. All right. Thank you very much. And I can take questions for a little bit. Yes, question?
So in the Spinnaker demo,
Yeah.
you build a new image with a new tag.
Yes.
You deploy that tag, but the manifest that you retrieve from source control has another version. How do you maintain that manifest up to date as part of your deployment?
Yeah, that's the magic there with, there was a section called artifacts to bind. So my trigger, my trigger configuration creates me an artifact that I can pass into various stages in Spinnaker. And one of the stages is to basically replace that artifact that triggered it in the manifest that I told it.
But now, that manifest in source control is now not valid because that's not what the build is.
Right.
So is there something in your process that then you commit that new tag value into the?
There are some systems that do it that way, but in this case, you would not have that. You would not have basically the ability to do a kube control apply of that manifest outside of the pipeline.
So
Yeah, question.
Spinnaker.
Yes, Spinnaker.
Is the configuration of it only web UI?
The configuration of Spinnaker itself is through a CLI called Halyard.
Okay.
And then the pipelines can be configured via a CLI as well or through the UI. Yeah. Any other questions? Yeah.
So we have the whole Google build, right?
Cloud build, yeah.
So, and we have the Jenkins, and you can do the whole thing in the cloud build itself, right? So what are the pros and cons? Do you
Yeah.
see?
So the question is, what are the pros and cons of Cloud Build versus Jenkins? So Cloud Build is, I think, an easy way definitely to get Docker images. It also has the ability to define some workflow actions, but Jenkins's workflow management and build management is much more sophisticated. For example, recently they added the ability to retry a stage. We don't yet have that in Cloud Build. So there are some things that you'll find in kind of traditional CI processes that are not quite there yet. We are working on those types of features, but Jenkins has a more robust ecosystem of CI steps and workflow actions. Like, for example, one of the big ones is failure of a step running some other step in order to run debug. We don't yet have that. You would have to script that part.
The other thing, maybe no one else said as a question.
Yeah.
So on the CD part where you were triggering through Jenkins the CD,
Mhm.
and one of the things was that there were credentials which were stored on Jenkins,
Yes.
right? And then that's from a security aspect, it's not exactly a recommended approach. Then, given that, what would be your other recommendation to have a more secure way to do this?
So the question was, in one of the steps I showed credentials being added as Jenkins credentials into the build process. What would be a more secure way to handle that? And frankly, you could use Vault or any other mechanism that could be scripted in order to get those credentials. The KUBECONFIG or the Jenkins CLI plugin is just a helper to get the right context in an easy way. But you could also have a file that you're pulling from Vault, for example, and then deleting and using the KUBECONFIG environment variable to point kube control at that file. Question back here?
Yeah, in the Helm, like you're installing from the stable repository. So this repository will be storing some kind of registry or where exactly it is stored?
So the question was, where is the Helm chart live from the stable repository? And we have, if you go to github.com/helm/charts, that is where the main charts repository is. We actually host those charts in Google Cloud Storage, and that's where you're pulling them down from when you install.
Can you install the different version of Jenkins also from there?
Yeah, absolutely. So the question was, where can I install a different version of Jenkins than what's in the chart currently? And there is a field in that configuration API to just change the Jenkins image tag. Question?
You referenced configuring the default JNLP container.
Mhm.
Can you go back over that? Was that in your YAML definition?
So that's, it used to be more difficult. The question was, how do you configure the JNLP container in that pod spec? It used to be more difficult. You used to have to massage that and make sure that you had the right thing there. Today, the Kubernetes plugin actually injects that for you with the right version, with the right Docker image. You can set it yourself. I prefer to use whatever works with the plugin at the time. So yeah, you have a little bit of flexibility, but by default, it injects an additional container into your pod. Yeah. Question in the back?
Yeah, when you're using multiple Jenkins masters, do you recommend having also multiple Spinnaker servers or like a centralized Spinnaker server?
The question was, should I use, if I have multiple Jenkins, should I have multiple Spinnakers? I think that really depends on how your organization works. I've seen people, there is not a scalability limit in Spinnaker today that we've hit. We know that there are large Spinnaker installations that handle many, many pipelines a day, like in the thousands. So I wouldn't look at it from a scale perspective, but if you had some sort of policy boundary that you wanted to apply, you may want to do multiple Spinnaker instances. Spinnaker itself does have the ability to segment things into accounts and who can access which accounts and applications. So I think by default, no, you don't need to. But if you find a reason why you need to limit access, that's when you may want to look at it. Question in the back?
So how do we use GKE to actually do Docker builds within the cluster itself? Do you offer any guidance for, I'm sort of looking at this and wondering the caching implications.
Yeah. So the question was, how can I do Docker builds inside of a Kubernetes cluster? And we do have a tool at Google called Canico. Canico is an open source tool that runs basically the Docker build process, but without privileged containers. So you don't have to run a Docker daemon or anything like that. There was a follow-up question there, which was, how do I handle caching? Caching is now implemented, but not merged yet in Canico. So they will be working on that, and it'll be a shared cache between all of your Canico builders. Basically, we use the registry as a cache. Yep. All right. Any other questions? All right. Thank you.